Now about scenario selection for independent certification. This is one of the incidents that you may see on the roads today. On the specific incident, there were two serious injuries, a collision that may have been avoided with the help of automated vehicle systems. There are many different types of accidents happening all around Great Britain every day. And most of these incidents, perhaps all of these incidents, present an opportunity to help prevent the human error with the help of automated driving systems if they are as good as we want them to be. So when we look at it, we're looking at a total of roughly 685 collisions per day in Great Britain, with 75 of these injuries being serious and 5 of them fatal. That is a lot of information, and all these injurious incidents in Great Britain are kept are attended by the police, and the information collected from these incidents are kept in a database called STAS-19. And this is a very good starting point for us because it gives us the bigger picture every single injurious incident in Great Britain. And when we look at the extent of this database, we have over 250 incidents per year, and that gives us over 1 million incidents every 5-year period, which is what we usually use for road safety research the last 5 years. Now the question is, how are we going to go from this many incidents into a more manageable scenarios that we can bring into the simulation workflow? This is where something called a priori dashboard comes in. We created this a priori dashboard to basically filter the incidents in certain ways to identify those that are most common and perhaps more relevant for an automated driving system. And this, for example, could be perhaps a T-junction incident, side impact on a single carriageway, or it could be a rear-end shunt at the entrance of a roundabout, or it could be this specific one. Let's have a look at this one in specific. This is a fatal incident in a dual carriageway with a speed limit of around 40 miles per hour, a single incident, a single vehicle involved, and it was near a junction. Now, if you want to simulate this thing, let's try what we can do with the data available to us from Stats19, because Stats19 is very good for giving the bigger picture, but the issue is the detail may not necessarily be there to be able to help us develop these scenarios in simulation. So what we know from this incident is, first off, we know there was a single vehicle involved which was traveling westbound. We know that much, but what we don't know is, we don't know if that vehicle was in the first lane, second lane, or third lane. In fact, we don't know exactly which part of the lane or where the impact point was. The second thing, we know that there was a pedestrian involved in this incident, but once again we do not know the position of the pedestrian nor the direction of travel for this case. So as you can see, it's very difficult to simulate something like this very accurately. We can guess, but maybe we may be missing the most relevant part of this incident. This is where RAIDS comes in. RAIDS is an acronym for Road Accident In-Depth Studies. This is a program by DFT, which has been going on for at least the last 10 years in a number of different names before the RAIDS as well. It's basically, we have a team of collision investigators which are attending to incidents within a certain radius of TRL, and they attend the sites and collect much more in-depth data so we can get a better understanding about the individual details of an incident, which are then kept in the RAIDS database and the preceding databases. So what we've done is we basically matched those very common incidents with similar incidents from the RAIDS to be able to understand much in depth, a much more better understanding of what really happened there. So coming back to this one, if this is what we've seen, representation of what we've seen from Stats19 data, almost like a 2D, very basic influx type of situation. This is more like what we see from RAIDS, much more 3D because of all the information we have, and we have things like, we know about where the traffic lines were, where the relevant roadside infrastructure were. For example, we know the position of the vehicle much more accurately with information such as distance from the edge of the carriageway, or positioning at different phases of the incident. We know much more about the infrastructure, for example, things like surface friction, temperature gradient, super elevation, and much more. We know things like the point of perception according to the phases. We know the point of reaction, and we even know the point of impact in this database, which helps us reconstruct this in much more accurate way. But the question here is, if you can see, the interesting thing here is, why did this driver not see that pedestrian which was obviously in sight? And this is the biggest thing that is missing from STAS-19 data. There was, in this specific case, a bus waiting to turn left, which was blocking the pedestrian, and pedestrian thought the green light was lit for himself or herself, and they then decided to cross the road into the blind spot and in front of the vehicle. And this is actually based on a real raids case, a real fatal incident. It didn't happen here, but very similar type of junction. And as you can see, by bringing in the raids data, we are bringing in that vital information that makes or breaks this specific scenario, because there is no point simulating this scenario without the bus in there. So coming back to our approach here, you can see we started again with GB level data, STAS-19 data. By using the a priori dashboard, we filtered the data into more manageable and relevant cases for this scenario, and then we fed the selected scenarios into the simulation. And before that, what we done is we enhanced the selected scenarios with matching grades data, so we have a better understanding of what to send to the simulation, and that was then sent to the simulation. Now, in this project, we only focused on the real-world incident data from these sources, but in reality, there are so many other sources of data we can bring in to the simulation workflow in the future. We envisage there to be a dedicated incident database, such as rates, maybe perhaps only for automated and connected vehicles, so we can understand the unique challenges that those vehicles are facing. Because let's be honest, yes, we expect them to reduce incidents caused by human error, but they can introduce new types of issues that we may need to solve through various means. So we envisage other data sources can also be fed into this in the future.